Q7308. What effect does high-density altitude, as compared to low-density altitude, have on propeller efficiency and why? A. Efficiency is increased due to less friction on the propeller blades. B. Efficiency is reduced because the propeller exerts less force at high-density altitudes than at low density. C. Efficiency is reduced due to the increased force of the propeller in the thinner air. The correct answer is B. Efficiency is reduced because the propeller exerts less force at high-density altitudes than at low density. High-density altitude refers to an altitude where the air density is lower, typically due to factors such as high temperature or high elevation. The air at high-density altitude is less dense, meaning there are fewer air molecules per unit volume. This has a direct impact on propeller efficiency. Propeller efficiency is primarily determined by the ability of the propeller blades to grip and move a sufficient amount of air. At low-density altitude, where the air density is higher, there are more air molecules available for the propeller blades to interact with. This allows the propeller to exert more force and generate greater thrust, resulting in higher efficiency. However, at high-density altitude, the lower air density means there are fewer air molecules for the propeller blades to engage with. This reduced air mass flow results in decreased propeller efficiency. The propeller is not able to grip and move as much air, leading to a decrease in thrust production. In summary, high-density altitude reduces propeller efficiency because the lower air density limits the amount of air available for the propeller to work with, resulting in reduced force and thrust production. 7308-1. What effect does high-density altitude have on aircraft performance? A. It increases engine performance. B. It reduces climb performance. C. It increases takeoff performance. The correct answer is B. High-density altitude refers to an altitude where the air density is lower, typically due to factors such as high temperature or high elevation. The reduced air density at high-density altitude has several effects on aircraft performance, including a reduction in climb performance. At higher altitudes with lower air density, the aircraft's engine and propeller receive less air mass for combustion and thrust generation. This reduction in air density means that the engine produces less power, resulting in reduced climb performance. The engine may struggle to maintain the same level of power output as it would at lower density altitudes, which affects the aircraft's ability to climb. With reduced climb performance, the rate of climb decreases, and it may take the aircraft longer to reach a desired altitude. The reduced power output also affects the aircraft's ability to overcome drag and maintain a steep climb angle. It's important for pilots to be aware of the effects of high-density altitude on aircraft performance. They may need to adjust their takeoff procedures, consider longer takeoff distances, and be mindful of the aircraft's climb performance when operating in high-density altitude conditions. 6744. Density altitude increases with A. An increase in temperature only. B. Increases in pressure, temperature, and moisture content of the air. C. Increases in temperature and moisture content of the air and a decrease in pressure. The correct answer is C. Density altitude is a measure of the density of the air in relation to its pressure altitude, which is the altitude indicated on an altimeter. It is an important factor in aircraft performance because it affects the lift and power output of an aircraft. An increase in temperature contributes to an increase in density altitude. As the temperature rises, air molecules become more energetic and spaced out, leading to a decrease in air density. This decrease in air density at higher temperatures results in an increase in density altitude. Moisture content, specifically water vapor, also plays a role in density altitude. Moist air is less dense than dry air at the same temperature and pressure. Therefore, an increase in moisture content in the air leads to a decrease in air density and subsequently an increase in density altitude. Lastly, a decrease in pressure contributes to an increase in density altitude. As atmospheric pressure decreases, the air molecules spread out further, resulting in lower air density. This decrease in air density at lower pressures leads to an increase in density altitude. In summary, density altitude increases with an increase in temperature and moisture content of the air and a decrease in pressure. These factors collectively affect the air density, which in turn influences aircraft performance. Pilots need to consider density altitude when evaluating aircraft performance and making decisions related to takeoff, climb, and landing in different atmospheric conditions. 6745. What would increase the density altitude at a given airport? A. An increase in air temperature. B. A decrease in relative humidity. C. An increase in atmospheric pressure. The correct answer is A. Density altitude is a measure of the density of the air in relation to its pressure altitude. It is an important factor in aviation as it affects aircraft performance, specifically lift and power output. An increase in air temperature contributes to an increase in density altitude. When air temperature rises, the air molecules become more energetic and move apart, resulting in a decrease in air density. As air density decreases, the density altitude increases. This relationship between air temperature and density altitude can be explained by the ideal gas law. According to the ideal gas law, as temperature increases, assuming other factors such as pressure and moisture content remain constant, the density of a gas decreases. In the case of air, as temperature rises, the air becomes less dense, leading to an increase in density altitude. It's important for pilots to consider the effects of temperature on density altitude when planning flights and evaluating aircraft performance. High density altitude can reduce aircraft performance by affecting lift and engine power. It can result in longer takeoff and landing distances, reduced climb performance, and decreased engine efficiency. In summary, an increase in air temperature increases the density altitude at a given airport. This is due to the decrease in air density as the air molecules become more energetic and spread apart. 6746. Which statement is true regarding takeoff performance with high-density altitude conditions? A. The acceleration rate will increase since the lighter air creates less drag. B. The acceleration rate is slower because the engine and propeller efficiency is reduced. C. A higher than normal indicated airspeed is required to produce sufficient lift since the air is less dense. The correct answer is B. Takeoff performance is affected by various factors, including density altitude. Density altitude is a measure of the density of the air in relation to its pressure altitude, and it has a significant impact on aircraft performance during takeoff. In high-density altitude conditions, which are typically associated with hot weather or high-elevation airports, the air density is reduced. This reduction in air density affects engine and propeller efficiency, leading to a decrease in the acceleration rate during takeoff. The reduced air density at high-density altitude means that there is less air available for the engine to generate thrust. Engines rely on the intake of dense air to produce the required power output. With reduced air density, the engine's ability to generate thrust is diminished, resulting in a slower acceleration rate. Additionally, propeller efficiency is also reduced at high-density altitude. The reduced air density affects the ability of the propeller to generate sufficient thrust and efficiently convert engine power into forward motion. This further contributes to the slower acceleration rate during takeoff. To compensate for the reduced air density and maintain the necessary lift for takeoff, a higher than normal indicated airspeed is required. Indicated airspeed is the airspeed read directly from the aircraft's airspeed indicator. By increasing the indicated airspeed, the aircraft can generate enough lift despite the lower air density. In summary, with high-density altitude conditions, the acceleration rate during takeoff is slower due to reduced engine and propeller efficiency. A higher than normal indicated airspeed is necessary to produce sufficient lift in the less dense air.